First, I'm going to start out with our flagship product, Visual CAD/CAM. We are running the latest release 2018. Now, feature detection can be performed on prismatic parts similar to the one that you're looking at here, or parts that do not have any sculpted surfaces or sculpted bottoms. So parts like these would work great, ideal for feature detection and machining. Now, the features on these parts, ideally you would want to be working with a solid model where it's made up of poly surfaces and not individual surfaces. So you want to make sure the geometry that you're working with is a solid model. So once you have a model imported, could be a step file, it could be a parasolid or one of the solid file formats that can be imported into the CAD system here. Once you import in a model, you'd want to go down to the Features tab, which is under the Machining Objects browser. You could have the Machining Objects browser docked below the machining browser, or you could have it docked over on the side right next to the machining operations browser as well. So you'd want to go into the Features tab in the Machining Objects browser, and you will find Automatic Feature Detection. So when you select Automatic Feature Detection, it automatically analyzes the part and identifies all of the different feature types based on the geometry. So you can notice that in this particular scenario, you're seeing that there is two orientations identified, orientation 1 and orientation 2. So by default, for users who are running the standard configuration, there's only one orientation the features would be detected on, and that would be based on the orientation of the machine coordinate system that's being established. Now, if you're running the expert configuration, where the machine type could be 4-axis, the orientations that would be identified are in the direction normal to the rotational axis, so that would be along the 4 sides, your top, front, bottom, and back. So if you're, if the rotation axis is defined along the x-axis, you would have the 4 sides normal to the rotational axis. If you have the orientation on the y-axis, it would be the 4 sides normal to the, rotational axis defined. Now, in the case of professional and premium configurations, the orientations will be established for all 6 faces. So consider a box which has 6 faces. So if you have features on all 6 faces, it would identify features on each of those 6 faces, and it will list them as orientations 1, 2, 3, 4, 5, and 6. Now, on this particular part, since there are features only on 2 of the faces, one is looking down from the top, and there's a feature down on the bottom face, so there's only 2 orientations possible where you can identify features, and it automatically identifies the features on each of the orientations if you're running the professional or the premium configuration of our CAM products. So with the standard configuration, it would automatically identify the features that is normal to the machine tool coordinate system that is defined, or in this case the world coordinate system seems to be in the same orientation, and the machine coordinate system is in the same orientation as the world coordinate system. Now, once you have the features identified for each of the orientations, as you expand each of the orientations in the tree, you will see that there are different types of features that have been identified. We have planar face features, so as you select the feature in the tree, the corresponding features are highlighted on the graphic screen in the viewport. So we have a planar face feature, you have prismatic pocket features in here, and as you hover the cursor on each of the features, the depth and the feature information is automatically displayed as a tooltip. We now have hole features identified. We have chamfer features identified on the parts, and you can see that the depth and the angle of the chamfers are also automatically determined, so it makes your programming workflow a lot easier. And we also have open slot features identified in here. And we have hole features and planar face features identified for orientation number 2. Now, once we have these features identified, the goal here is to go from feature detection to feature machining. So automation of the feature detection and feature machining is the goal. So automation makes it easier for you to program it. So once you have a feature identified, you can just select the orientation 1 And as you click on automatic feature machining, this will automatically generate toolpaths for each of the features that are in that particular orientation. Now there is a default knowledge base that's already set up in the program, and we'll go over in detail how this knowledge base can be modified, edited, customized, and changed to your machining needs. So by selecting the automatic feature machining, it'll automatically generate toolpaths for each of the identified features, and it maps the features to the corresponding operations in here. So now what you're seeing here is we have a facing operation, we then have a pocket operation for the closed prismatic pocket, a profile operations in here for both the planar face and the prismatic pocket, slotting operations for the open slots, and finally we have a chamfer operation in here. So I'm going to go into the setup and run a simulation in here. So I'm going to pick simulate. I can do a right click and do a simulate, or I can go to the very last operation in the tree and choose simulate until, and this would run through the simulation for each and every operation. Now as you notice in this particular sequence of operations, the holes aren't being drilled or machined. The default knowledge base that we currently have set up does not have a hole operation linked to it, and we'll talk about how we can update the knowledge base to also include the hole operation as we progress along during this webinar. So we've identified several different types of features on this particular part: planar face features, prismatic pocket features, hole features, chamfer, prismatic open slot features. Now we'll take a look at another part where we have a different set of features, and we'll see how we can identify those features as well. So for this, I'm going to switch over to our plugin for Rhino. We're going to be talking in RhinoCam, taking a look at part in RhinoCam. So again, here we have a prismatic part, which is, I would say, fairly complex, has several different feature types in here. And let's go ahead and identify features on them. So the workflow is very similar. You would go to the Features tab under the Machining Objects browser. So you could either have the Machining Objects browser docked below the machining browser, or you can have it docked right next to it. So if you'd like to have an expanded view, you'd want to go down to the Features tab and click on Automatic Feature Detection. We call it AFD, Automatic Feature Detection. So now this automatically identifies all of the features based on the configuration you're running. If you're running the Pro, it'll identify features from all the 6 different orientations like we talked about, if you have features on each of the 6 different orientations. Again, on this particular part, we have only 2 orientations. We have orientation 1 and 2, which is the top and the bottom. And as you pick an orientation, it automatically displays the direction of the orientation, the normal, as you can see it on the graphic screen. And the orientation 2 represents the bottom of this part, the bottom face of this part. Now under orientation 1, we have a planar face features. We have 3 different planar faces, and as you select each of the planar face, the corresponding planar face is highlighted on the graphic screen. You have prismatic pockets. We have 2 prismatic pockets on this part. We have several different open prismatic pockets. We now can identify open pockets with bosses as an open prismatic pocket. So as you generate a machining operation for an open prismatic pocket, it automatically treats the islands, the boss features as islands, so that the cutter will not go past the island areas. So you can generate a facing operation for open prismatic pockets with automatic feature detection with these operations. So we now have open prismatic pocket features in here. There's 5 different open prismatic pockets. We also have boss features on this part, so we have 3 different boss features. And as you select each of the boss features, the corresponding features are highlighted. And you have hole features as well, 2 different types of hole features. They're automatically separated based on the hole diameter and the feature cross-section. So we have 2 different types of hole features in here. Now again, once you have these features highlighted, you can go up to the top level and click Automatic Feature Machining, and this would generate toolpaths for each of the features that is identified. So you can see that there are several different operations that have been created. And we have the facing operation in here, which basically has generated the toolpath for the open pockets, and it automatically honors the boss features as island and not to cut into, and the exterior part extents is treated as the extent the cutter can go past it, so to clear the material around it in here. So the feature detection and automatic feature machining helps you reduce the number of button pokes, clicks that you have to do to create your toolpaths and automates your workflow. So the goal here is to automate everything to make it easier to program your toolpaths. Now let's go ahead and run a quick verification in here. I'm just going to go to the very last operation, right click and choose simulate until, and you will notice that we were able to program and simulate each of these operations in here except the whole features on this particular part. And we'll talk about how we would be able to add the whole feature operations into the knowledge base as we go through the webinar today. Now, when the machining operations are programmed, the depths and all of the parameters are derived from the features, so you do not have to go in and re-enter in any of the depth parameters. As you edit the operation, you'll notice under the cut levels tab, the depth is determined from the feature, and also by default the depth per cut parameter is already set. If you need to make any changes, you can always edit the operation and update each of these parameters in the operation and generate the toolpath to update it. Now we talked about how we can select an orientation in here to program a toolpath, where you can select one of the, the orientation 1 or orientation 2 to program it. You could also individually select a feature and generate a toolpath. So for example, if you'd like to program just the prismatic open pocket feature number 1, you can highlight it and just click on automatic feature machining, and this will automatically generate the toolpath for the feature that you selected. You could even select a group of operations. In this particular case, I'm going to select the group which is the prismatic pockets, the closed prismatic pockets, and I can select automatic feature machining, and this will also generate the machining operations for the closed prismatic pocket. So there's a pocket operation for as a roughing toolpath, and then it's followed up with a profile operation as a finishing pass. So you could generate automatic feature machining either by selecting an orientation, or you could select a feature type to program it. Now let's take a look at what are the types of features that we can identify in here. So I have this little slide which basically talks about the different feature types. We could identify whole features, prismatic pocket features, open prismatic pockets, boss features, and general 3-axis pocket features. This is if you have a cavity with a sculpted bottom, you could identify them as a 3-axis pocket feature. Slot features, both open and closed slot features can be identified. Open slot features, T-slot features, V-slot features, general 3-axis open pocket features, so parts with sculpted bottoms. We could also identify planar face, fillet, chamfer, and step pocket features. So these are the different feature types that we can identify in our latest release. Now the next thing we're going to talk about here is how we can automate drilling, detection of drilling features and machining them. So in order to go with that, I'm going to bring in an example in here to talk about drilling features. So what I have here is a fixture plate which has several holes on it, and there's holes of different sizes in here. As you can see, we have all of these different size holes. Now these could be either through holes, or you could have them as blind holes in here, and we can identify all of these different holes based on the hole cross section and also the size, the diameter of the hole. So the process would be very similar. You would go over to the Features tab and then select Automatic Feature Detection. So in this particular step, it analyzes the part and identifies each of the features, and you can see that there's a planar face feature detected, and we have several different types of hole features. As you can see, there's 5 different types of hole features. As you hover your cursor over each of the features, it represents the hole diameter and the depth for each of the features, and all the holes of the same sizes in the part are grouped under a feature. So you can see that there's basically a total of 18 holes that are of a specific diameter and depth. So they're automatically grouped as instances, and we have hole features 1, 2, 3, 4, and 5. So you can see that we have holes of different sizes in here. So 4.2 millimeters, 6 millimeter holes, 9 millimeter holes, and then we also have 6.8 millimeter holes in here. Now once you have these features identified, we would like to go ahead and automate the process of programming the toolpaths on it as well. Now before I select automatic feature machining, I want to point out in here that we have a library of tools that are loaded on this part, and you can see that we have tools of different sizes in here. So we have tools of sizes that would match the hole diameters. We have 6 millimeter, 4.2, 9, 4.95, and 6.7. So basically we have drill tools that have the same diameter as the hole diameter. Now as I go into the Features tab and select the orientation, and when I pick automatic feature machining in here, so this would automatically go ahead and identify the holes and generate toolpaths for each of these features in here. So that's what we're going to take a look at in here and see how we can generate toolpaths. So I'm going to select the orientation 1 and pick automatic feature machining. And as I generate the toolpath, you will now notice that there's a facing operation and the profile operation generated for the planar face, and then we have drilling operations generated for each of those hole features. Now as you select the standard drill 1, you will notice that it automatically chose the tool that's equal to the diameter of the hole. So it's doing automatic mapping of the tool to the feature, so based on what you have in your library. So it'll look for a closest diameter tool that's equal to the diameter of the hole feature that you identified. If there's a one that's closest to it, it'll automatically grab that one that's equal to the diameter of the hole. If not, it'll pick the next closest one, which is equal to or less than the diameter. So you can see that automatically it selects the tool for it. So this makes your workflow a lot more easier and a lot more simpler. Now as you edit a machining operation in here, so if I pick one of these operations, I double click on it, you can see that the diameter of the hole feature that's detected is 6 millimeters, and it automatically chose the 6 millimeter tool. We now have filtered list and also full list of tools. The filtered list shows all of the tools that can be used for this particular feature based on the tools that you have in your library. The full list basically lists all the tools that are available, so you can switch between filtered list and full list, but you'll notice that automatically the tools are mapped to the operation based on the hole features that are detected and the tools that are available in your library. So this is a very nice feature which makes your programming workflow a lot simpler by just having to load your tool library, and after you identify your features, you just select automatic feature machining. Now the next thing we're going to talk about is how we're going to do interactive feature detection and how this is useful and how we can also do interactive feature machining as well. We'll also talk about interactively feature selection as well as we go through today's webinar. Now to demonstrate the interactive feature detection and feature machining, I'm now going to bring in another example in here, so which we're going to cover during this webinar today. Okay. So what I have here is a part that has features on different orientations. So we have features on the top orientation and one of the sides, I do not have any features on the bottom or on the front or the back. I have a feature on the top. I have a feature on the right. I also have a feature on one of these angle faces in here. Now, as I go into the Features tab and choose Automatic Feature Detection, as I pointed out earlier, it will identify features in each of the 6 faces if you have features on them. So in this particular case, if you consider a box, there's a total of 6 faces. However, there's only features on 2 of those faces, which is the orientation 1, which is the top, and then the orientation 2 is the right side face. So when you have features that are on angle faces, something similar to the one that you're looking at in here, you can select the orientation interactively by using interactive feature detection. So in this particular step with the interactive feature detection, you just need to pick a face to establish the direction for the orientation. You could be selecting a face either on the top over here, or you could be picking a face either on the floor of the pocket that you have. So you just have to pick a face, and then when you press right click, right mouse button click, it will identify the features on that particular face that you chose. So the interactive feature detection can also be used if you only want to identify a feature on a certain given face. So in this particular part, rather than having to identify the features on the top and then the side face, if you only wanted to identify one of these faces, you could use interactive feature detection, so it'll identify features on the face that you chose. Performing an automatic feature detection will automatically identify features on each of the 6 faces. If you're running the Pro or the Premium configuration, or if you're running the standard configuration, it'll be normal to your machine tool coordinate system. If you're running the Expert configuration, it'll be along the normal to the axis of rotation, which could be the 4 sides. Now in this particular case, we did the interactive feature detection where we were able to pick a face and basically detect the features. Now you'll notice that on the face that you chose, you have a planar face, you have prismatic pocket feature. So as I selected, those features are being highlighted, and we also have a hole feature in here. Now I could select all of these features in here. So I could go ahead and select the top of the feature tree, and if I select automatic feature machining, and if I have the knowledge base set up for each of these orientations, it will automatically generate toolpaths for each of these orientations under a different setup in here. So you have setup number 1, which has a planar face and a slot feature. So you can see that there is a slotting operation generated for setup number 1, followed by setup number 2, which should be the right side face. You will have a facing operation, a pocket operation for the closed prismatic pocket in here, and you have a profile operation that would finish the pocket. And you have setup number 3, which would be for the feature that you interactively detected, and we automatically generated the toolpath using the AFM. So we have facing, pocketing operations, profile operations for it, and we have the whole feature operation in here as well. So you can establish these knowledge bases, and you can have different knowledge bases. You can choose which knowledge base to be applied for automatic feature machining, and we'll talk about that, how to create those knowledge bases and how to customize those knowledge bases as well. So one of the ways to program it is, after identifying the features, is using the automatic feature machining. Now let's take a look at how we could interactively select the features for machining. So once you have these features detected in here, you could go over to the graphics screen and you can interactively select the features. So as you hover over these features, you will notice that it automatically displays a tooltip with the feature name on it. So in this particular case, I have a planar face. I can right-click on the planar face, and it'll interactively tell you what are the operation types that can be used to program a planar face. So if you have a planar face, you could be doing a facing, a roughing, or a profiling operations. And I can select facing and generate a toolpath for it. And as you can tell, the depth and all the parameters are automatically determined. Now if I go over to the slot in here, if I hover the cursor on top of the slot and wait for a couple of seconds, it automatically displays this as a prismatic slot feature. Now as I right mouse button click on it, it tells me that the type of operations I could program for the slot would be a slotting operation. I can right click and select slotting, and you'll now notice that the slot feature is automatically added to the control geometry, which is the part feature. You make a selection for your tool, and you'll also notice that the cut parameters are automatically set up in here. If you'd like to change the depth per cut, you can always modify it here. The total depth is automatically determined based off the feature, and when you pick generate, the toolpath is generated for that particular feature. Now if I go over to one of the side faces in here, again I can generate a toolpath for the planar face. I can select the pocket feature, right click on it, and I can choose pocketing as a roughing operation and then a profiling. So based on the feature type, if it's a closed pocket, you could program a pocket operation, or you could be using a profiling operation to do a finish after you do a roughing operation with a pocket. So right click and pocketing, and again you'll notice that the depth is automatically determined based on the feature, and then selecting generate creates your toolpath. So once I'm through with the pocket operation, I could follow it up with a finishing, which could be a profile operation in here. And all of the information is automatically populated based on the. Likewise, I could do the same step over here for the prismatic pocket. Right click on the prismatic pocket and choose a pocket operation, generate it. So for each of the orientations, it automatically creates a setup, and you'll notice that your machine tool coordinate system is automatically oriented based on the orientation of the feature. So this is called interactive feature selection and interactive feature machining. So as you select a feature, you right click on it, you could choose the operation that you'd like to program, and it automatically determines what operations can be programmed based on the feature that you select. Now if you pick a pocket prismatic closed pocket, you can only program a pocket or a profiling operation. You can't program a facing operation for a closed prismatic pocket. So the system is very smart enough to figure out based on the feature type what operations you can choose. So it automatically filters them out for you. So it makes your programming workflow a lot more easier in here. Folks, again, if you do have any questions, please feel free to post those questions in the questions panel, and we'll do our best to answer them for you here. Now the next thing I want to go over is the similar type of feature interaction, how you could do it in RhinoCam as well. So I'm going to go back to this part that we had looked at earlier. So you can graphically select these features. So as I go and pick the prismatic open pocket feature in here, you can see that the corresponding feature also is highlighted in the tree, and you could right click on the feature, and now you can see that for an open prismatic pocket, you could program this with a facing operation. So right click and choose facing, and again the depth information is automatically determined from the feature. You can control your depth per cut, and you can also control your roughing, your entry and exit, any additional parameters, and choose generate to create the toolpath. So now your toolpath for the open pocket is created. Now if you'd like to program the prismatic open pocket for the feature beneath the top open pocket, you can right click on it again and choose facing and generate the toolpath for it. So the toolpath is now generated for the open pocket. You can always edit the operation, double click, you can click on select features and go ahead and interactively select additional features as well. So as you edit the operation, it automatically lets you pick those prismatic open pockets in here. So I have those 4 prismatic open pockets selected. I could do a right mouse button click now and choose generate to generate the toolpath, and now the toolpaths have been generated for each of those 4 prismatic open pockets. So you can edit an existing operation that is generated based on features to add or drop features from the machining features list, or you can graphically go ahead and select these features and generate a toolpath. For example, if you pick a boss feature in here, right-click on a boss feature, and you can choose to run a profiling operation, and the depths are again automatically determined based on the feature. So we have a profile operation that's generated on the boss feature. And if you need to make any edits or modifications, you can always edit the operation in here and change your cutting direction or your depth per cut. Each of these parameters can be updated. So interactively, you can select the features that are identified, and you can also interactively generate the toolpaths, machining operations for the selected features. So this basically gives you an overview of how you could interactively identify features, select the features, and also generate toolpaths. Now the next thing we're going to talk about here is how we will be able to customize this knowledge base and where this knowledge base is being loaded from. We're going to talk about that in here, and we'll go through an example and how we will be able to modify the default knowledge base and also create new knowledge bases to be able to associate feature types to the operation in here. And in order to go over this, I am going to go ahead and bring in another part in here, and we'll talk about the workflow of how this is being done. So I have another example loaded in here on my graphic screen. So I'm going to go into the Features tab and select Automatic Feature Detection. So when I select Automatic Feature Detection, this is exactly similar to what we looked at earlier. It identifies the different types of features in here. So we have planar face features, we have prismatic pocket features, open prismatic pockets, and we also have whole feature operations in here. And in addition to that, we have chamfer features on it. Now, under the Features tab, you have several different tools and controls in here. Now, as you go into Create Machining Knowledge Base for Milling Features, this displays on the left pane here, it displays all the available features that can be identified or detected. And over on the right side, once you select Load Automatic Feature Machining Knowledge Base, which is Load AFM Knowledge Base, it loads the default knowledge base that's mapped and saved in your installation folder. So as you take a look at each of these operation types, now the system has automatically, we have a mapping in the knowledge base for a roughing operation. You could have boss features. You could also have planar face features for it. So for example, if you pick planar face on the left pane, it tells you that what are the operation types a planar face can be programmed. So a planar face can be programmed in a roughing operation, a facing operation, and a profiling operation. So you can drag and drop these features from the left pane over to the right pane. If you pick a prismatic close pocket, you could be programming either a pocketing operation and then do a finishing with a profiling operation. If you choose a prismatic open pocket, you'll notice that you could program facing and profiling operations. So as you select each of these operations in here, it automatically filters the operation types that can be used with. So for example, if I choose a step pocket, I could do a pocketing and a profiling operation. So if you have a fillet feature, you could be programming a filleting operation with it. So this knowledge base in here, the Load AFM knowledge base, is basically found in the Feature Machining Knowledge Base folder. So as you go into your CAM preferences and select the Features option, you will notice that there's Automatic Feature Machining Knowledge Base, and by default, you will notice that this is saved under the Visual CAM 2018 and then Feature-Based Machining KBs folder. If you're running RhinoCam 2018, you'll find it in RhinoCam 2018 and Feature-Based Machining. And there's two knowledge bases in there, the default AFM inch, and there's a default AFM mm for millimeter units. So if you're working in inch units, it's automatically mapped to the default AFM inch knowledge base. If you're working in the millimeter units, it's mapped to the millimeter units knowledge base. And that's automatically set in here when you run the application. So as you go in and choose create machining knowledge base for milling features, and if you click on load AFM knowledge base, it basically loads all the operations that are established in that particular knowledge base. Now let's talk about how we can modify this and customize this. If you take a look at this knowledge base, there aren't any whole features on this default knowledge base. So when I go ahead and program the automatic feature machining, so when you pick automatic feature machining, this actually generates the toolpaths from the from the features that is identified and maps it to the operations that are in your knowledge base automatically. So as you can see here, the facing operation was set to automatically program for planar face and open prismatic pocket. So you have two operations, one for the planar face, one for the open prismatic pocket. You have a pocket operation generated for the closed prismatic pocket, a profile operation for the planar face, for the open and closed prismatic pockets. You have a slotting operation program for the slot features, and you have a chamfer operation for the chamfers that are identified on this part. So as you can tell here, the drilling operations is not on the knowledge base that we use for the automatic feature machining. So how could we modify the knowledge base to also include the drilling features? So in order to include the drilling features, so since the hole features and the milling features are different feature types, in the case of hole features, you could have through holes, blind holes, you could have holes with a counter bore, or a holes with a chamfer, which could be like a countersunk holes. So those are identified as a separate category of features like hole features. In the case of milling features, you typically have either closed pockets, open pockets, and they all can be programmed as a milling feature. That's why we differentiate between holes as a separate feature types versus the milling features. So as you select the hole feature in here, you could go into what is called create machining knowledge base for selected hole features. And as you click on it, it displays the cross section for the holes. So it identifies this particular hole cross section has a through hole and also has a a countersunk at the top, like a chamfer feature at the top. Now you can choose what operation you would like to use for programming the hole features. I could choose to do a standard drill. I can drag and drop. So for hole features, these are the available operation types that you could use, and you can drag and drop them. So you could be doing like a spot drill and then a deep drill, or you could be doing one or more operations in here. Now once you've identified the operation for this particular hole feature cross section, you could save this operation in here into your automatic feature machining knowledge base. So when you click on save in AFM knowledge base, it appends this whole feature to the knowledge base. So it just saved it in the knowledge base. Now if I go back into the create machining knowledge base for milling features and load the AFM knowledge base, you will now notice that the whole feature that we just created is appended to the knowledge base at the very end. Now if you have whole features of different whole cross sections, in this particular example we have two different cross sections in here. So I'm going to pick the whole feature number 2 and click on create machining operations for these as well. As I select the whole features, you can see that this is a through hole. There aren't any countersunk or chamfer on this. And again, I'm going to pick an operation for this as well. I'm going to pick a standard drill and choose to save this in the AFM knowledge base, which is the automatic feature machining knowledge base, and I'm going to pick save. Now this also whole feature is added to the knowledge base. If you go back into your knowledge base of both milling and whole features, you will notice that the two whole features are now being appended to this knowledge base in here. Now once you have the knowledge base with these whole features appended, if you go back and generate an automatic feature machining, you will now notice that it has generated your machining operations for all the milling features, and you also have the toolpaths generated for the hole features. So there's two types of hole features in here. Now these two holes have a similar cross section, but the depths are different. It has a countersunk or a chamfer and a through hole. And this one also has a similar cross section, but the diameters could be different and the depths could be different. And again, here we have a through hole. So the toolpaths have been automatically generated based on the whole features identified in here for these. So you could now reorder these operations in here. So if you'd want to program the whole features before you do the chamfer operations, you can just do a drag and drop to reorder it in here after you generate the toolpath. Or if you'd like to have this automatically reordered in your knowledge base, you could still do that. The process would be by going into your knowledge bases tab in the machining objects browser. So I'm going to move this over to the side, go to the KBases tab, and load the knowledge base, which we just created here, which is the default AFM knowledge base. And you'll now notice that all of the operations in the automatic feature machining knowledge base are present in here, and I can now select an operation and reorder it by performing a simple drag and drop. So once I have this reordered in here, I can go back and resave this to the default knowledge base in here, or I can rename it or use it under a different name in here. So I can say I want to call this with a different name. So you can create knowledge bases with different names as needed, and you can prepare them for different types of parts or different class of parts that you're using. So you can build different feature-based machining knowledge bases for your programming needs. And once you create them, so I'm going to call this knowledge base with inch-3. I'm going to save this up in here. Once you have the knowledge base created and saved, you just need to go back and remap it in here. So you go into your CAM preferences, go down to features, and then right where it says automatic feature machining knowledge base, you change it to the knowledge base that you'd like to use for automatically generating your toolpaths. So once you have that established, I'm going to go ahead and clear out these operations. If I pick automatic feature machining, you will now notice that it uses the knowledge base number 3 that you pointed to, and the machining operations are generated for each of the milling features. After the slotting operation, you'll notice that the whole features are being programmed, and at the very end, you have the chamfer operations programmed for it. So now if you go ahead and run a verification, right-click and do a simulate until, you'll notice that the holes are also being programmed in here in the knowledge base. So you can customize your automatic feature machining knowledge base by going over to the features tab. You can add or remove operations. You can also customizing them by selecting the type of features that you'd like to use for it. So for example, if I go into the associate features and load the AFM knowledge base, I could choose what features to use. So I could say, for example, for the roughing operation, I would also like to include a planar face feature. I can do a drag and drop in here. So it'll automatically add the planar face feature to a roughing operation. If you want to delete a feature, so for example, to delete a planar face feature from a profile operation, I can select the planar face and hit delete, and that'll remove the feature from the operation type. Now when I pick save in AFM knowledge base, it automatically updates your knowledge base that you're pointing it to with these changes. So now the profiling operation will only be able to generate operations, machining operations for these feature types if those feature types are identified in the part that you detected features for. So this gives you a precise control on how you can customize the operations and map it to the feature types that you'd like to use with it.